So, hello everyone, let's start with the XDC Tech Webinar 3.0. Good afternoon. Welcome to XDC Tech Webinar 3.0. Today we will be diving into account abstractions by Etherspot on the XDC network and its advantages with a live demo led by our expert, Mr. Satish. Thank you, Satish, for joining us. We are also excited to have Mr. Nikhil from the Etherspot with us, who will showcase the features of the account abstractions with the live demonstrations. Before we get started, here is the introduction to our team. So my name is Omkar Mistry. I am head of technology and engineering at XDC Network. Along with me, Mr. Anil Chichawle, actually the head of software development at the XDC Network. Suresh Nagar, who is managing social media with XDC Network, and Rishabh, he is a project manager and uh, onboarding multiple startups, and he looks after the integration. So now, without any further delay, let's dive into the presentation. Over to you, Satish.
Thanks, Somka, for the introduction. Let me quickly share my screen. So let me know if once you're able to see my screen.
Yes, sir.
Okay, perfect. Okay, thank you everyone for joining to this webinar. So a quick intro about myself. I'm Satish. I work as a blockchain engineer at XDC Network. I do work on like developing dApps and kind of researching on the latest tech stacks to be implemented on the XDC network. So today we are going to talk about account abstraction. So I just have a quick like 5 to 10 slides followed through by a demo, and then we'll have Nikhil from Etherspot who will be running you through the various components of Etherspot. So I believe at the end of this session, you would be able to have an understanding about what account abstraction is all about and how it's going to actually make the user experience and Web3 onboarding seamless. So let's start with the introduction. So before diving into account abstraction, I just want to give you a quick introduction about XDC Network. Just 2 to 3 slides just for you to understand the specs and capabilities of the network. So XDC Network is a layer 1 EVM compatible enterprise grade blockchain solution. So we are up and running since 5 years. So, and you can see some of the like interesting stats about the network is we have achieved like 2000 transactions per second with less than 2 seconds block time and with a near zero gas fee. So that's one of the major highlight about the network. So you can do transactions. It's like similar to like you can just think of like it's a zero cost, but yeah, you're just going to pay a minimal fee. So these are some of the stats about the network. And so XDC network, since we designed it for the enterprise grade, so the consensus mechanism is more safe and secure. So the consensus mechanism we have is XDC 2.0, which requires like 2/3 of the master nodes to sign each block. So currently we have 108 active master nodes and more than 200 standby nodes. So this makes the network more secure with the help of hot stuff consensus mechanism. And just a quick view about some of the major dApps, interesting dApps built on the network. So there is like a big list of dApps which you can go through zinfin.org, ecosystem dApps. There are like a lot of dApps being built on the network. But these are the some of them to highlight in the RWA space, DeFi, gaming, and the education and the medical space. So yeah, let's dive into account abstraction. So before going into actually what account abstraction is all about, just let's consider like what are the challenges the Web3 industry is facing currently. So I would like to highlight 3 of them. First one is the private key dependency. So when you want to log into any of the Web3 platform, right? So you need to have a wallet installed on your browser, like for example, XDC Pay or MetaMask. You need to save and securely store your private keys, and you need to have the seed phrases, and all those needs to be done. So there is a that's of a major concern, and that's the first step for any user to come into the Web3 platform. and this makes the onboarding process very difficult, because if you lose the keys, you lose all the access to your platforms and the funds in your wallet as well. So the other one is the gas fee complexity. So as a user, I log into a platform, but still I will not be able to use the platform once you even have the MetaMask wallet, right? So any of the platforms, like any blockchains you consider, need to have the native token to be paid as a gas fee. So that's make the process still more complicated. And currently, yeah, whatever we are talking about, the XDC Pay or the MetaMask, those are called EOAs, right? So they are externally owned accounts, and there is like a limited things you can do with it, right? So if you're going to accessing a DeFi platform, you need to like do multiple steps. Like for example, you need to approve a transaction and then you need to submit a transaction. So that makes things more complicated, right, for a user. So if I want to onboard a platform, it's not just like simply I can do it as similar to a Web2 platform. And these are the challenges the current users are facing. And there are some solutions to it which account abstraction can address. Account abstraction actually creates something called smart accounts. So you don't need to have again a MetaMask wallet or anything, but account abstraction gives you a flexibility to have smart accounts. And account abstraction, along with wallet infrastructures like Web3 Auth and Magic Link, makes the process more seamless. So which means like when a user onboards, it's just like matter of seconds. You can just use your Google or any of the social logins to be onboarded to the platform. So that's one of the power of account abstraction, which is called smart accounts. You will be learning more about that in the upcoming slides. And the next one is gas abstraction. So account abstraction gives you a capability to have paymasters who can pay the gas fee on your behalf. And that gas fee will be like paid by the platform you're accessing. So which makes the user process more simple. So the user no need to have the native tokens to be paid as the gas fee, right? So that makes the process more simple. And the power of account abstraction is programmable transaction, which means you can actually code the way you want your wallet to work. For example, you can have like whatever you do on EOS, right? It's just based on your approval, you do the transactions. But when you talk about account abstraction, we have something called smart accounts, which is actually a smart contract, right? So as it's a smart contracts, it's actually flexible to have your own logics. So you can say like, I need these two addresses to sign the transaction, or I need this to be done for particular transactions to be done. You can basically specify your custom logics. And there is more enhanced security, as with the account abstraction we can have like time locks and other limitations. For example, you can if you're using a DeFi platform, you can limit your spendings per day, like how you do with your bank account. Simply as simple as that, you can limit your account, say I want to restrict like 1,000 tokens for this particular transaction or a particular day. So which makes the process more like convenient for the users, and everything gets abstracted. So that's why the term account abstraction. So it's the account, but it's completely abstracted from the user. So yeah, this is what we discussed so far. Like traditional EOA accounts like XDC Pay or MetaMask, any external wallets want you to manage the private keys and pay the gas fee. And yeah, you cannot define your custom logics, and it makes the process more tedious. So yeah, jumping into the components of the account abstraction. So there are like majorly 5 components when you talk about account abstraction. I'm not going to dive very much deeper into that, but just to give you a high level understanding how the flow is working when compared to the normal transaction on any other blockchain. So in account abstraction, we have 5 components. The first one is user operations. So when you talk about user operations, so this is basically you can it's something like a normal transaction, but it has a lot more other details when a user submits a transaction. Um, you have more details when you compare to the normal transaction of the network. Uh, then this user ops goes to bundler. So the bundler gives you a way to bundle the user operations. So what are happening so far? It's not onto blockchain as of now. So the first user operation comes from the user, and then it goes to a component called bundlers. So the bundler is going to actually bundle your transactions, which means even you can submit like 2 or 3 transactions together. So the previous example I spoke about, So in a DeFi platform, you can combine your approval and the payment steps both together. So which means like the pop-up which user gets like 2 or 3 times, he need to approve it each and every time on the EOS is completely eradicated. So this has been given to the smart contract accounts, smart accounts basically. So the bundler is responsible for bundling the user operations, and then we have the entry point contract. So for any of the blockchain network, entry point contract, it's basically a singleton contract which validates and executes the user operation. So when you're submitting a user operation before it going on chain, so the user operations has to be validated, like whatever checks we do in a new usual like transaction. So entry point does similar kind of simulations with the user operations which has been submitted, and then it makes sure that you have necessary like a gas fee to pay for the transaction, and then entry point contract submits the transaction through the mempool. And after which we have a couple of components like called paymasters and aggregators. So these, the first three are the must-have components for any of the account abstraction infrastructures. But when you talk about paymaster or aggregators, it's a good to have, and it provides you more convenient and flexibility. So the paymaster is responsible for sponsoring a gas fee. Say as a platform, I implemented account abstraction along with paymaster, which means like the user no longer need to pay the gas fee when they are doing any transactions on the network, and that particular fee will be bared by the platform, and which in turn be collected from the user in terms of the transaction fee. So this makes sure like the user no need to have the native tokens. And aggregators is some one more component good to have, which aggregates the signatures of all the transactions from the user ops. Like we might have multiple transaction, instead of validating each and every transactions one by one. So aggregator like basically validates all the signatures in one go, and which makes the process more seamless. So this is a quick flow diagram, and you have better flow diagram here. So these are the components we spoke about. First we have the user, and then we have the bundlers, followed by the entry point, paymaster, smart contract, wallet on the blockchain. So the user submits a transaction, so the bundler combines the transaction and submits to the entry point, which is going to simulate and validate the transaction. And if there is a paymaster, it's going to see if the paymaster approves the gas fee, because even though you're on a platform which has paymaster, your address needs to be approved by the paymaster to be able to sponsor the gas. So that's the step next. Once the paymaster approves, it's going to the smart contract wallet and confirm the execution, and then it returns back the approval to the bundler. Then bundler, now having approved from the entry point, the validation is done, and the paymaster confirm like the gas is going to be paid by the paymaster for the on behalf of the user. So once everything is confirmed, the bundler is going to submit the transaction on chain. And this process, all these processes is going to happen like within like a fraction of seconds. Like it's not going to take like 5 or 10 seconds or like a minute or so. It's going to be like so fast. Like even this happens in a real time. So you'll get to better know the flow and what's happening in the backend when I walk you through the demo. But on the whole, this is the all about the flow of account abstraction. And yeah, these are some of the major use cases which like any of the Web3 platforms can easily adopt. The first one is gasless onboarding, which means like the user no need to pay the gas, and the platform like pays the gas fee for the user. And then there is something called session keys, like this especially for gaming. So which can like you can have a pre-approval for a predefined time. So as like the normal session keys, which will have a validity like either for 24 hours or like 48 hours based on your configuration, that can be done with the help of smart accounts. And yeah, DeFi automation, right? As we spoke, right? You can actually put your custom logics on the block on chain, like on the smart contracts, which means like you sell the token. This is like how you take the positions in the market, right? So you sell the tokens if the price drops below this particular E or like XDC. And then we have like the gaming applications, which especially this account abstraction, I would say like it's a very much suitable for a gaming application, because as a gamer, I don't want like the pop-ups, or I don't want to worry about the gas fee, but I just want to have the complete end-to-end process seamless. So this account abstraction, I think, is a boon for the gaming industry. And then we can have the subscription models, like you talk about Netflix. you can basically configure like I need to pay with USDC or any other tokens for my subscription, and that gets automatically detected based on your pre-approvals. So these are the major use cases I see which account abstraction can support, but there is a lot more the industry is adopting. Yeah, having walked through the demo, walked through the slides, I would like to give you a quick demo. So what we did at XDC Network is, so we have the account abstraction infrastructure provided by Etherspot, and also we have the wallet infrastructures provided by Web3 Auth and Magic Link. So these two are the main components for making any Web3 onboarding seamless. So what we did is we designed, developed a utility in XDC Network, which is called XGate. So this is the repository. So XGate is a combination of both Web3 auth and account abstraction. So you will see on the, and we have like, this is open source and anyone can just clone it and try to run it. So when you actually see this in the demo, right? So you'll be able to understand like how you will not even feel this is like a Web3 platform. This will feel gives you a feel similar to a Web2 platform. So I'll just walk you through this demo. So this is like a what do you call this is like a component which any of the dApps can integrate with. So consider like I have a gaming application which is developed on Web2, but when I migrate the same to Web3, so as we discussed, we need to have the wallet installed for the user. I need to have the seed phrases, I need to store the private keys. I need to have the gas and each and everything, right? But once you integrate this particular utility, which is a combination of Web3 auth and account abstraction by Etherspot, so you will see like how this feels. So as a user, I'm trying to log in. So now what happens, I no need to create any, I no need to have the MetaMask also. So I just going to sign up to this platform using my Google account. And you have Facebook, Discord, and you can just even use your phone numbers. And once you have this, in the behind what's happening, like behind the scenes, is basically Web3 auth is creating a wallet for you, and it stores all the private keys and everything for you in a safe and secure manner. And if you're just using Web3 auth without account abstraction, so again, this is the account which has been generated. That if you have not used Web3 auth, this account would have been generated when you install MetaMask. But as we integrated Web3 auth, you have this account now, which is like generated by Web3 auth. So which makes sure like you don't need to have your private keys or seed phrases safely and stored securely by yourself. But this particular component Web3 auth makes sure like it takes care of you and more like it stores it in a more safe and encrypted manner. There are a lot of crypto algorithms they followed, and even some of them like split your private keys into different parts and store it in a different clouds. So that's how like they make the process completely secure. And as this utility has account abstraction installed, so what happens is this is kind of considered like a EOA address which has been generated by Web3 auth. And with account abstraction, we can generate any number of smart accounts for a particular EOA account. So for this particular EOA account, currently we have generated like 3 smart accounts. So let's consider this is the smart account we are going to use. And this platform will have a separate utility where you need to whitelist this particular address to be able to sponsor the gas fee. So that has been already done. So I'm going to just take a particular action. For example, you're on a platform and you want to mint ERC20 tokens. So I've just taken a simple example for you to understand and see like how things are working beneath, right? So what I'm going to do now is basically, I'm going to just take any wallet address. I'm going to paste it here. Okay, before that, what I need to do is I need to check the balance of the smart account. Okay, so this is the account we are going to use to submit the transactions. So, okay, so you can see now the balance is 18.8180. So what I'm going to do now, I'm going to submit mint ERC20 tokens. So which this smart account is going to submit. So let's use today's date is 29. So let's mint 290 tokens. So the first example you're going to see is going to use account abstraction, the smart accounts to submit your transactions, which you will see like when you submit a transaction, the MetaMask will no longer pop up. So with what you have done is so far you have given your EOA permissions to your smart accounts. Now smart accounts is going to submit any of your transactions on behalf of the EOA account. So which means you don't need to have the worry about like submitting or signing a transactions. So I'm going to mint simple ERC20 tokens. The first case I'm going to do is without the use of Paymaster. So which means like even though we are using account abstraction to submit the transaction, still this account is going to pay the gas fee. So now the balance of this account is 18.81. So I'm going to mint. So you can see there is no longer any pop-ups that you can see the transaction as we spoke about the user ops. So these are the user ops. You can see like similar to any ordinary transactions, you have the sender, you have the nonce. So you can see just in a matter of like 2 to 3 seconds, like with the speed of XDC network and account abstraction by Etherspot. So this has been completed even like within like 2 to 3 seconds. So just think like any of the platform integrate this utility to their application. So you're not going to face any kind of like a delay waiting for the like transactions to get completed. So you can see already the transaction is completed and the tokens are minted. So this you can see like visibly like how speed XDC network is like in processing the transaction, like the block time of 2 seconds, which we spoke about. So now you can see 290 tokens has been already minted to this address. And after which you're going to still check the balance of this particular account. Okay, you can see there is like a minimal amount of XDC has been detected from this account. So this example uses like smart accounts to submit the transaction, but without paymaster. So which means this particular address has paid for the transaction fee. I'm going to do the same action again with paymaster. So mint with smart account plus paymaster. So you're going to do the same action again now with help of paymaster. So you're going to submit the transaction. So just for the simplicity of understanding, I have taken this example of minting a ERC tokens, but this can be any action on any platform. Like this is like a simple transaction to the blockchain. So this can be like any of the actions you're doing with on the blockchain. So I have submitted the for the approval. So the user ops has been done. So it's just waiting for the paymaster to complete it. So it's done now. So we just want to verify the transaction. So you have all the details out there. You can see in 6 seconds, like you have submitted this transaction 6 seconds ago, and this is completed, and 290 tokens have been already minted. So now that's now there's the interesting part. So this is a smart account. Okay, just for you to make sure, I will check the balance now. Hopefully, it gives me the right answer. Okay, so this is the new balance. So you can see the balance is the same. So which means the user no longer have paid the gas fee, and the particular gas fee for this transaction has been already paid by the paymaster. So what as a platform, what I need to do is I need to host my paymaster, and I need to like credit that with fund it with a specific amount of XDC tokens. The beauty here is like even with one XDC tokens, you can do like 100,000 of transactions based on the gas fee of the network. So which means like even if you have like based on a user base and the volume of transactions you're doing, you can fund the paymaster with a specific amount of XDC tokens, and this has been already paid by the paymaster. So you can ask the question like why I need to like sponsor it for my user. The answer is like just to make their user experience seamless. So like you can get like more option to your platform compared to any other platform that requires to have like native tokens for the gas fee. But you're not going to leave it with that. What you're going to do is like anyways you will be collecting a transactions fee from the user. So you're going to compensate from that. As a user, like I'm going to pay XDC tokens as a transaction fee. You're going to collect like a few percentage of that from the user as a transaction fee, but at the same time you're going to pay the gas fee on their behalf. So I think this would have given you a good understanding like how account abstraction actually powers and like helping the user onboarding experience more seamless. So I think that's a quick and short demo I had just for you to make you understand the flow. And yeah, this utility, as I mentioned, is like open source and anyone can like free to like clone it and run it on your local. And so we have like xdc.dev where we have a lot of articles account abstraction about that. So you can just have a look, and if you have any queries like you're facing when you're integrating account abstraction onto your application, so you can feel free to leave it on your this forum, and we have like more than 2 to 3K active community members who are happy to help you out. And yeah, I think that's it from my side. So a quick understanding about the account abstraction and a short demo. So please feel free to follow this particular link to get any tech or any updates from the network side. So I think I would now see if there is any quick questions. Otherwise, I would like to hand over the mic to Nikhil, him to walk through about account abstraction by Etherspot and yeah, the developments.
Thank you, Satish. Uh, excellent presentation of how the found execution works on the network. Before we move the Etherspot presentation, the floor is open for anyone. Like if anyone has a question for Satish, please feel free to ask, or maybe you can type it on the chat box.
Yeah, thank you, San, for confirming. Yeah, but I will be on the call still. It's like if you have any questions at the end, yeah, I'm happy to take any Q&A. Thank you.
Okay, then if there is no further questions, we can move to the Nikhil. Hi, Nikhil.
Yeah. Yeah. Thank you for the demo. It was a comprehensive demo, sir. Yeah. Let me share my screen. Let me know once you can see my screen.
Sure.
Is my screen visible?
Yes.
Yeah. So I'm Nikhil. I've been working as a developer at Etherspot for about 6 months now, and the journey has been amazing at Etherspot. So basically, just to give a quick introduction about Etherspot, how did it came to existence and all. It all began as a initiative called Pillar Wallet, which was a EOA based wallet, which was started. The team has been since 2017, and then it was a EOA based wallet, and then at the even before there was wider adoption for L1 and L2s, which was not there at that time compared to what we have today. After that, we kind of noticed and got to know the difficulties of using EOA based wallets, and then we started the innovation for smart contract wallets and account abstraction. Since then, to expand on this innovation, it was branded under the name called Etherspot, and since then we've been working on the account abstraction and chain abstraction front. So yeah, let's get started. So in this, as part of this presentation, I'll be walking all of you guys through the various products and services the Etherspot has to offer, and then later followed by a demo on the modular SDK, which Satish used for his demo application on the UI. I'll be walking through the code and explaining how it can be used to leverage account abstraction on any wallet or DApp for that matter. So yeah, so these are the various products or services which Etherspot has to offer. One being Modular SDK, which is completely open source, developed on TypeScript, and it is compliant with ERC 7579. Uh, and it's completely modular, wherein you can have, it has utility functions for to sign user ops, to validate user ops, and to sign transactions. And then it has utility functions, since it's compliant with 7579. It has utility functions to manage your modules which you install on top of your smart wallet. So yeah, and then we have Arca Paymaster, which is basically responsible to make possible the gasless transaction or the sponsored transactions. We have support for token paymasters and verifying paymasters and multi-token paymasters also, which allows user to not worry about gas at all. Maybe pay gas using a completely different token, like any USDC or USDT stablecoins. And we have multi-token paymaster support also, wherein with one smart contract deployment, you can choose to use whatever ERC20 tokens you have to sponsor for your gas. And we have Skanda Bundler, which is a 4337 bundler client, which uses alternate mempool to relay the transactions, bundle them together, and relay it to the chain. Which also has the capabilities for P2P connections with other bundler clients using the shared mempool architecture, which basically makes the user ops more resilient. So that with the shared mempool architecture, if even if a bundler client is down, it will relay your user operations to other bundler clients, so that user operations, the success rate for user operations will increase drastically. And we have chain abstraction solution, which is being worked upon using the concept of shared session keys, wherein user doesn't even have to worry about what chain they are on, and then they can just express their intent as to what is the desired output they want. And then with using the concept of session keys and solver nodes, we'll be able to s- solver nodes will basically satisfy the user expressed intent, and then user does not even have to care about what chain they are on. So that's being worked upon currently. And we have multi-chain APIs, wherein there are a lot of utility functions which any DApp or Web3 product can ask for, be it getting your balances for your account, or getting the transaction history, getting the transaction receipt, or getting the transaction routes or the smart contract routes which you would need to make cross-chain swaps and all of that. We have APIs for all of them on the multi-chain level. We have support for over about 30 plus chains, including testnets. And then coming to Transaction Kit is a React library which uses Prime SDK and Modular SDK under the hood, which gives you React components out of the box, which you can use on the UI to sign transactions, sign user ops, estimate user ops, and then send transactions also. And then Prime SDK is compatible with entry point v6, and Modular SDK is compatible with entry point v7. Yeah, moving on. I think Satish went through the components of account abstraction. These are the three major, components for any account abstraction solution. We have smart contract paymaster, and bundler. With Etherspot infrastructure services, using smart Etherspot paymaster, it can completely enable the gasless transactions. And we have social logins for better user onboarding and user experience. And then we have one-click transactions, enables one-click action transactions, wherein if you have let's say multiple operations which you have to do, all of them can be performed with one transaction. And then we have session keys. The technique of session key is that you create a new session key pair on the fly, and then you authorize those keys to be valid for a certain spending limit or certain time period. And then that session key, whatever you created, will have the capacity to withdraw funds even without your intervention. So that's about session keys. And this session key is also being extended to the chain abstraction solution, wherein the solver node would upfront the liquidity, and then using the session key, whatever is created on your smart wallet, it can be used by the solver back once the user expressed intent is satisfied. And then we have recovery options on the Etherspot smart account, wherein you can add guardians, mm, always ensuring that your funds or assets, whatever is stored on your smart wallet, are always safe. Then we have sponsored gas again, wherein user does not have to worry about, they can make gasless transactions. And then, or if they wish to pay using a separate ERC20 tokens, they can do that as well. And then no need for seed phrases, of course. Uh, Unlike the traditional EOA accounts, you do not have to worry or keep the store your seed phrases at all. So coming to the ERC 7579, this is one of the prominent EIPs which enables the modular smart account architecture. I'll just walk you through with this ERC what it does, which is important to have a good understanding on this, followed by the demo, which will uh, walk you through with how it is compliant with 7579 and how we can manage modules using Etherspot Modular SDK. Uh, so with this ERC, the major benefit of this ERC is that it unifies and standardizes the smart wallet implementation. Prior to this EIP, what used to happen was the smart contract wallet implementation between organizations or between implementations used to differ a lot. Because of that, there was a lot of friction uh, with integration. Uh, Module developers would always have to worry that if this module might not work with any other smart contract implementation, and it was almost impossible to develop modules which would work and easily integratable with all the smart wallet implementations. So this ERC makes sure that it gives us a unified standard for smart wallets, which will help reduce the friction. And again, it increases the interoperability between account to account interactions also, because the standard has been defined, and then all of the smart wallet are expected to have those implementations in place. And then this enhances the module composability also. As a result, user in a single user operation can invoke multiple modules to have to achieve the complex use cases, to achieve complex use cases. Yeah. And then this simplifies the integration a lot, minimizes the fragmentation, and it allows developers to get innovative, and they don't have to worry about if it would work on every smart contract wallet as such. Yeah. Because the standard is in place, the module developers can get innovative, and then they can develop the module so that it would work on all of the smart wallets which are compliant with 7579. So this is a diagram which I have, which would briefly explain about how smart contract wallet uses various 7579 modules. This is a DApp which would interact with the smart wallet, 7579 compatible smart account. And then this smart account can internally have all of these kind of modules. These are the four different kinds of modules which we have. One being validators, hooks, executors, and fallback handlers. Validator modules would always have functionalities like to validate a user of, let's say, if a user is trying to, if a smart account wallet is trying to execute a user of, validator module would have the functionalities which would make sure that that all of the checks done are correct, and then the user ops are validated. And then we have hooks, which would contain the pre and the post checks before any execution happens. Like, let's say if I want to execute a user operation, before the user operation is executed, if a hook is installed to a smart wallet, then the pre-check is kicked in before is executed before the actual execution happens. And then once the execution is completed, the post check would kick in, and then that execution would happen, which would make sure, if you want to have like any, let's say, a simple example would be, if you want to have a event emitted from your smart contract, that can be done easily using hooks. And then we have executors itself. Executors would define how a user operation should be executed. And then the fallback handlers, which would basically extend the fallback functionality of your smart contract wallet. Uh, let's say the usual practice is to have a Solidity fallback handler inside the code. and then if you have the 7579 compatible modules installed on your smart wallet, you can define your own logic as to how you want that fallback function to function. Yeah. And then a little bit about Etherspot Modular SDK. It has extensive module support, and then it is 7579 compatible, which is safe and secure. And it's fully open source, developed using TypeScript. Just to give a quick kind of what are the modules that are widely being used. You can just search 7579. These are the various modules which are being under which are under active development, or some of them which are already developed. If I can open multiple owner ECDSA, this is one of the modules developed by Etherspot, which is a validator module, uh, which wherein you can have multiple owners for your same smart wallet. And then we have ERC20 session key validator. I'll be demoing this in a bit, which will basically have the functionality to uh, create a session key, and then using that session key, you'll be able to send ERC20 tokens without even having the signature of owner. So yeah, these are the two prominent, important validators which is developed by Etherspot. And then we have something called credible account module also, which is under active development, and then which is going to be used for chain abstraction solution. And moving forward. And then I would like to speak a little bit about 7702 and then head to the modular SDK demo. 7702 being EIP 7702 being one of the prominent EIPs upcoming in the featuring in the upcoming Pectra release of Ethereum, which basically allows EOS to temporarily behave as a smart wallet, and which is completely compatible with 4337. Also, which aligns in line with the future roadmap of Ethereum on the account abstraction front. So wherein here it introduces a new transaction type, and then it adds a new field called contract code, wherein you can just specify what is the contract code that you would need for your EOA, and then that contract code, whatever is there, would be replaced with your actual EOA itself, and then which can benefit all of the account abstraction features, of course. And then once the transaction is completed, the EOS would come back to being the normal externally owned account which it was. And then there is a similar EIP called similar EIP 3047 3074. 7702 is better than this because it is both forward and backward compatible with 4337, and then 3074 also has a requirement to add new opcodes like auth and auth call, which is not needed in case of 7702. With this, EOS can function as a smart wallet for one particular transaction, which can further increase the user onboarding and reduce the gas fees also. And then this is the RLP, recursive length prefix transaction object, wherein these are the old ones which we already have: the chain ID, nonce, priority fee, the 1559 gas parameters, and then we have gas limit, and then we have access list. These are all something which is already there, and then we add something known as the access list, wherein you specify the contract code, and then the signature of your EOA itself, which is authorizing, saying override my EOA with this particular smart contract code for this transaction. So yeah, this is a brief diagram about how EIP 7702 works. This is your smart contract account bytecode, and then with the major advantage with 7702 is that you do not have to incur for smart contract wallet deployment itself. You can always just override your EOA with the smart account wallet code, the bytecode itself, and then still be able to do 4337 transactions. So we have the user over here, and once he signs a user up, we will have the smart account bytecode overridden, and then we will have something called as delegation address, to which the transaction has to be delegated. Once the signature is done, the bundler would check for the 7702 signature, and then once it's done, the necessary access list, whatever I showed in the slide previously, would be added to the transaction, and then the transaction is carried out on that delegation address which the user signed on top of. So that is how the EAP 7702 works. That's all I had for the slides. Let's now go to my VS Code editor, and I'll uh, walk you through with the how you can use the Etherspot modular SDK to perform user operations. Sorry, yeah. Do we have questions?
Hello.
Hello, yeah.
Nikhil, just let's take 10 minutes for questions, and then you can start with the demo. So as we have,
Okay.
yeah, so let's take the questions now, and after taking these questions, and we can just continue with the demo.
Sure, makes sense.
So I guess we have a question for Satish by Christian. How does account abstraction compare with other layer 1 blockchains implementing the business solution?
Oh yeah.
I mean,
so-
I'm not sure if I quite understand the question correctly. How does AI compare with other L1 blockchain implementing similar solutions? What are you comparing against? I'm not sure if I quite get that. And also, answering to the other question, how does AI affect that developers on XDC in terms of wallet integration? I mean, with using the AI solution, it would definitely increase the user experience in the first place, wherein you do not have to. You can basically batch multiple transactions, wherein user does not have to worry about signing multiple times. You can batch multiple transactions at once. I think one of the best examples which even Satish spoke is, let's say if you are doing a swap transaction on any DEX for that matter, uh, always you would have to do two transactions. One is for approval, one is for doing the actual swap itself, but you would have to still wait for the first transaction to reach finality, to have a confirmation on the first one. Only then you can do the second transaction. But with AA account abstraction, you'll be able to batch those two transactions together. Either both of the transaction would happen or none of them will happen. I mean, there are various SDKs. One being Etherspot Modular SDK itself, which is compliant with 7579, which I'll be demonstrating shortly. I think that is the same SDK which Satish also used for his demo on the reactor.
Yeah, Nikhil. Standard. Okay, so yeah, I think Nikhil, I would I think Eddie, if you're fine, yeah, good. But I would also like to share my screen now. So if you're a developer and if you're looking for the integration, so I'd like to show you a quick look at the code as well. Okay. So yeah, this is some similar app like which we spoke about, right? Like if when you whatever you want, the code level examples is present in XGate. So just log in, try to access this, and if you see this, you have all the like SDKs what are required. It's completely integrated. And when you talk about the SDKs, right? So we have used Etherspot's modular SDK for the integration here. And if you can see, just for this example, just to actually really show you like how it's working. This is one of the app which has integrated account abstraction, right? So you can see for this particular operation. So like for example, you want to redeem a product on a platform, and you need to give a approval for the like platform address or any of the other address, right? So what you do usually when you use UA is basically you need to have like this particular actions done separately. Like you need to do couple of EOA approvals on your EOA wallet like XDC Pay or MetaMask. But what you're doing here is you're just bundling this transaction. Say I have approve, then I have like also the redeem. So these two approvals can be combined together, and you can submit to like a bundler, and even you can even have these redeem transaction that can be bundled together. So basically, all these transactions can be bundled together, and then you can submit it to the paymaster. So you can see the paymaster detail is here. So don't worry, these codes are present in the repo which I shared. So it's just you clone the repo and modify your logics whatever you want, and it's gonna work like straightforward. So yeah, this is just a code level example I just wanted to show. Yes,
Yeah,
Christian. So
just
XDC
to
Network. Yeah, go ahead, Nikhil, please.
Yeah, just to answer to Christian's question, saying does XTC network follow 4337? I mean, it does not really depend on the network as such because 4337 doesn't need any changes to the consensus layer itself. It basically uses a alternate mempool. Uh, Without if any of the networks are compliant with EVM, then it's definitely compatible with 4337 also. It's just that 4337 standard is that defines that we use a alternate mempool on the bundler, which would bundle the transactions together and then relay it down to the network. So it does not really depend on which network we are on, as long as it's EVM compatible, of course.
Yes, Nikhil. Just to add on to that, like as Nikhil mentioned, any of the EVM networks can easily adapt account abstraction 4333 standard, I mean 4337 standard, having by having these components and alternate mempools. But yeah, there are also some research going on in the space to have like you can even Nikhil was having in his slide in the space of 7702. So this 4337 doesn't need to have any core level changes. Like what I mean is like there is no get level changes or core level changes required. But yeah, there are some research is being done in this space to even have this natively supported on the chain instead of having all these components separately. And even chains, I think if I'm not wrong, it's ZK Sync. Even they have their own native account abstraction at the core level itself. So yeah, some chains have adapted it early when the chain was being developed, but all other EVM chains can have this account abstraction support with 4337. So I think if there are no other questions, maybe Nikhil, you can please go ahead with the demo. We can take the questions on the chat.
Okay, sure. Yeah, I have my Etherspot modular SDK cloned. I can just, if you want, you can just head to the Etherspot GitHub repository and search for Etherspot modular SDK. You'll be able to find that. And then once you have cloned it, just do npm i to install the dependencies, and then I think you should be good to run all of these example scripts which we have. These example scripts would give you the best understanding, I would say, on to how Etherspot modular SDK functions. And then also make sure to have a .env file with your private key and then a chain ID. In this case, we'll be using XDC testnet, which is 51, which I have already added to the .env file, which I have here. So yeah, these are, let me just walk you through the directory structure of what we have under the examples here. We have some scripts for basic transactions, like let's say send native XDC testnet crypto from your modular account. And then and also we have the how to get the create to address for your associated private key which you have injected. And then but for this examples we will be directly using a private key injected provider, but then that can easily be any other provider, like let's say MetaMask provider or any JSON RPC provider for that matter. And then we have add guardians, wherein you can add guardians to enable social recovery. And then we have get call limit, and all of the basic things are in this directory. And then we have module related module management scripts. Like, let's say if you want to install an external module, then you can do that using this script. If you want to uninstall, you can use this. And then to list all of the modules which are already installed, you can use this. And yeah, basically the module management scripts, whatever are there, examples are under this. And then we have paymaster, wherein you can how can you send transaction using Modular SDK to enable gasless transactions. And then we have session key related functionalities over here, where you can enable session key for your particular smart wallet. And then how you can disable a session key, how you can transfer ERC20 for the key which you enabled. Transfer the ERC20 tokens for using the session key for which you enabled it. So yeah, let's start with the basic ones now. I'll do get counterfactual address first. What this does is this would give you the create to address of your smart wallet. I'll just do npx ts node samples basics, and then counterfactual address. This should give me my smart contract wallet address. So this is my modular smart account address, which is pre-computed using create to. If you want to have different multiple modular accounts for the same private key, then you can use this multiple to get the multiple accounts. I'll just say get multiple accounts. This should give me two different modular accounts itself. Let's say the difference being I'm using index 1 over here, which you can keep increasing as long as how many other accounts you want. For the by default it will be 0. If you want to have different different modular accounts for the same associated private key, then you can always increase this index or change this index, which should result in a salt change for a create, which is a create to component, resulting in a completely different address of your modular account. So that's that. And then we have get. Also, one more important thing to note over here is the bundler API key, whatever I am using right now, it's a free public key which we have enabled to for users to come and run examples on top of. But you might run into some rate limiting issues because of this. If you want to have a legit key, then you can always do that by heading over to the dashboard, developer.etherspot.io, wherein you can manage your manage your API keys. You can just create a new key over here and then use that key there, and you should be good. And then this developer dashboard also contains functionalities for paymasters, wherein you can manage your paymasters. Let's say for this key, if I want to manage my paymaster related functionalities, then I can deploy my verifying paymaster specifically for your key. And then you can basically choose around networks over here. In this case, you can choose 50 or 51, and then you should be good. And then if you want to, once it's deployed, you'll be able to use sponsor or deposit funds to your paymaster contract, and then you'll be able to enable gasless transactions for whatever modular accounts you whitelist. Yeah, once this is deployed, you will basically have functionalities to whitelist and manage your addresses accordingly, sender addresses accordingly. So that's about the dashboard as to where you can get the API keys. Once you have the API key, just replace it with this, and then I think that should be good. And then moving on to the next example, we have get gas fees, which is basically getting the 1559 parameters of any chain. Now let's say I'll just replace this with get gas fees. This should give me the max priority fee and the max fee per gas, which is the 1559 gas parameters, which you can make use to send any user ops. And then let's see, we have get nuns, which would give me the nuns for your particular smart account, which is basically one of the parameters in your user operation itself. And then if you can see, this is a pretty huge number, because the reason being this also encodes your validator address within itself. That's how the implementation of Etherspot wallet works. We have the validator address encoded over here. I mean, this is the place wherein we specify which validator we would use for this particular user op. By default, we have the multiple owner ECDSA validator already installed. uh, for my private key which I am using, I have already deployed the smart wallet. So the the module has already been installed. I'll get to that more when I'm explaining about the modules. Now let's just send a few user ops to check and get an understanding of how does the code work there. Uh, then transfer funds. Here, basically, I have a recipient address and I have how much value. This is the native crypto value, how much I want to send. And then I'm just doing get modular instance, which is a helper function within the examples itself, which should give you a instance of modular SDK. And then these are just some helper logs to get a good understanding of how it is working. And then I have transaction batch. This is wherein we add actually the transactions itself. You basically use modular SDK dot add user ops to batch, wherein you can add multiple user operations. If let's say there is approve and send ERC20, then you can just do that with this. Wherein if there is call data, since this is a native crypto transaction, we do not have the call data. If you have the call data, then you can do it on the data field. You just have to add the call data over here and then add it to the transaction batch. You can add multiple operations on the same modular SDK instance, and then you would get a transaction batch, which is just a helper log over here. And then these are also just the helper logs. And then we estimate the transaction to see if all of the user of whatever is there which we are trying to send is correct. If everything is good, then we would just do dot send, which would get the hash of your user op and then sign on top of that hash. And then we would continue to wait for the transaction hash, basically to get the finality for that transaction. So yeah, I mean, the flow remains same for any transaction you send, just that the way we estimate changes. I'll get to that when we go to the paymaster module. Uh, Basically, the flow remains same onto how you want to add user ops to how you want to add user ops and then add transactions to one batch and then send it to the bundler. Uh, and also, if you want to use a separate bundler, by default it uses the hosted Skanda bundlers of Etherspot. If you want to, let's say, use some other bundler for flexibility, we have, if I can just go inside this, you can also specify your own custom bundler URL as well. You can just say RPC URL and then it can change. I mean, I don't think that was here. I think that was here. Yeah. Uh, you can just say what is the custom URL that you want to use, and then you can just give your custom URL here, and then you should be good to use it is flexible that way. You don't have to rely on Etherspot's bundler itself. It will work for any other URLs also for that matter. Uh, and then let me just do a user op and then say transfer funds. This should basically, so this is my transaction batch which I'm trying to execute, and this is my balance which I have, and this is the estimated user op. Now I have got the user op hash. Now we are just waiting for the transaction to get the transaction receipt basically. And then yeah, once we have the transaction receipt, let me just open this on the Explorer to check if everything's okay. Yeah, this is the transaction hash, wherein if you notice here, um, this is the user op which I wanted to perform, and these two are the accounts for the gas whoever paid. Like in this case, this was the address which relayed the transaction for us, and then that's basically, that relayed address is basically getting back whatever it paid for gas. That's all. So yeah, this is how we send user ops using Modular SDK. It's always we estimate, add transactions to the batch, how many ever transactions we need, and then just do dot send, and then the user op should be bundled with the hosted bundler, and then you should be able to get the transaction receipt back. And then let's just do ERC20 to get an understanding of how we can do that. I have already deployed a sample ERC20 token just for this demonstration purposes. And then I'm trying to send 0.1 of it. Let's say this is my modular account address. If I open this address on the Explorer, you can see I have one token called gold. I have 9.79 of it, and I'm trying to send 0.1 of it. Yeah. Replace this with ERC20. And again, the same thing happens, and then we would get the user operation hash back and then wait for the confirmation. Yeah, that's that. And then we have verify signatures, wherein this example would give you an understanding as to how you can sign messages using Modular SDK. The same thing here, we get the Modular SDK instance, and then this is the type data on top of which I want to sign on. This is the sign v4 method which we use internally. And then this is the public client which I am creating using the hosted bundler, Skanda hosted bundler setup. And then I have my sign data over here. You just have to do modular SDK.sign type data and then send in the type data, which should eventually include the domain types and whatever primary type and what is the actual message itself you want to sign on top of. And then there is the normal sign message, which is basically signing your personal message. And then the validations are happening here to check if the those two are valid, like the signature is valid or not. I can just run this also. My signature, which should basically give a log saying the signatures log, and then giving a log saying if it's verified true or false. That's all. And then moving on, let's see the add guardian thing. I'll just run through as to how you can add multiple transactions, right? Like I explained before, these are the different call data which I have. In this example, I'm trying to add in 3 guardians, and then I have these 3 guardians. And this is specific to the Etherspot modular account itself, because we use multiple on the ECDSA validator. This works on Etherspot wallet itself. And I think feel free to walk through the examples for transfer NFT also. That should also work the same way. And then moving on, let me just walk you through the paymaster example also, wherein we have the transaction details over here. And then for API key, we are using Arca public key, which is a public key enabled on Arca, hosted Arca, which is a paymaster service. And then the bundler key remains the same. And then in this case, we would use this public key, which is only valid for testnets, of course. For to make it work for mainnets, you would have to get a entirely new API key, which I just showed. The same API key works for both bundler as well as Arca also. And then you'll be able to use that to get the paymaster signed for sponsored user ops. And then the same thing here, the difference being in this case, when you are estimating, previously when we were estimating, we were not specifying anything else. We were just doing dot estimate on the modular SDK instance. We were just calling the estimate on top of it. Like, let's say here, this is a transfer fund native crypto transfer example, wherein we are just calling the estimate on top of it. Whereas in this case, we would specify the paymaster details and say what is the context. The context being sponsor for native paymaster sponsor. If you want to pay using a separate ERC20 token, then you would just have to do ERC20 and then specify the token with which you have to pay. Of course, if it's supported, only then it would work. Otherwise, you will be reverted otherwise. So yeah, that's how you can sponsor. Right now, I cannot demonstrate that, unfortunately, because we do not have ERC20 tokens set up for XDC network. And then if you want to use multi-token paymasters, then you can just do multi-token, which should enable you to use the multi-token paymaster deployed instance to pay for gas. And then, yeah, I think the flow remains the same. I think Satish has also demonstrated this as to how the paymaster thing works. Yeah, and let's just run it anyway. Um, yeah, this should sponsor me sponsor me gas using the public key of Arca. Notice that in this case, the paymaster and data is not empty. If you have noticed the other user ops, the paymaster and data used to be entry for other user ops because you are not making use of the paymaster. And then yeah, this should sponsor for gas. And then let's see, we have session keys, which would help you enable session keys for a particular modular account. And then yeah, modules, of course, let's just go through this first and then go to session keys. Let's say in this case, I will try to install the session key validator module into my smart wallet and then try to run an example. Let's say, let's do ease module installed first. And then I'm trying to get if this particular module is installed or not, which is, I think, the multiple owner ECDSA validator module. Let's do modules and module installed. This should give me a Boolean if it's installed or not. This is, I think, the address of multiple owner ECDSA validator deployed instance. That's why this came out to be true. And then let me just grab the session key validator contract address also. Should be here. Yeah, this is the ERC20 session key validator. If I can replace this with this, it should give me a log saying if this validator is already installed or not. And then this is just an enum for module type, which can be hook, executor, or the fallback handler, like I explained on the slides. So yeah, it came out to be true because I have already installed the ERC20 session key validator. Let's go on to install module. The same thing happens here as well, wherein you just use the modular SDK dot install module, then you specify what type of module it is, and then you give in the modular deployed module address. If there is a init data, then you would optionally give the init data also. For our validators which we use, they do not have the init data. That's the reason I have left it empty. If there is some custom external modules which you want to install on top of Etherspot modular account, then you can just specify that in the third optional argument. And then yeah, let me try to install module. I think it should revert me back because I have already installed it. This again being the ERC20 session key module, yeah, it would revert saying it's already installed. And then you have uninstall module also, wherein you can uninstall your module from. So basically, that's the advantage of modular 7579 compatible wallets. It's just plug and play. You can install any module you want anytime, or uninstall any module anytime you want. And then let's use list modules, which should give me the list of all of the modules which are already installed. It should give me two addresses, one being the multiple owner ECDSA, which is the default validator which we use for Etherspot modular account, and the other one being the session key validator which is already installed. Let's enable a session key using this now, since and also to note is that this enable session key would work only if you have installed your validator ERC20 session key validator already. If not, it would fail. So just make sure to keep in mind to have this installed already before trying enable session key. So yeah, in this example, what we are trying to do now is that we have the modular SDK generated already, and then we are basically using a session key validator on top of this, and we are using .create on the modular. Yeah, this should create a new session key, and you can make use of that session key whatever is created and to transfer the funds. Yeah, this is the brand new session key which you just authorized your modular smart account on for this particular function selector, and this is the token address which the modular account already has. So yeah, you can just make sure to replace this particular session key in the rest of the examples, and it should be good. And the rotate session key would actually create a new session key, and it would basically replace the existing session key with the new session key, whatever you created. Mm. Yeah, I think that's all I had.
Thank you. Thank you for the demo. So question, what is an abstraction does provide it?
Chain abstraction solution, it's basically being built on. I mean, the work is still in progress. Um, we are basically planning to abstract away the chain. User does not have to worry about the chain at all in the first place. User can just come and say, I want these many funds on this chain, and then we basically have the solver in between which would upfront the liquidity, and then later with the same usage of session keys we'll be able to claim the funds back once the user intent is successfully satisfied by the solver. It is still being built on top of. It's not yet public, I'd say. Also, there is a YouTube video which I can share the link to, which explains about uh, which was basically part of the DevCon 2024 presentation. Yeah.
Yeah, just to add on to that. So as a layman, if you want to understand what chain abstraction is all about, so consider you have a solution deployed using chain abstraction, right? And you're using XDC network, and you have another network, consider Ethereum. So what you can do is basically, if you have, so the case now is if you have USDT, like any stable coin, right? USDT token on Ethereum network, and if you want to use that USDT token on XDC network, so basically you have to use a wallet and do the cross-chain transaction, right? So it again incurs a specific transaction fee, right? But when you do that with chain abstraction, so it gives you a feasibility to have USDT token in any of the chains. So what it means is, even you have USDT token on Ethereum or any other network, you can still use that token on XDC network. Similarly, if you have some token on XDC network, you can use it on any other networks. So it's like the step of like transferring a token from one chain to other chain, the cross chain transaction and the fee and everything will be like eradicated. So I think that's one of the core feature of chain abstraction, as I understand. But yeah, I think Etherspot is also like working on a solution, as Nikhil mentioned. So I think soon that will be out. Yeah, pleasure, Shan. So yeah, happy to take any other questions. Me and Nikhil are available.
Hi Satish, I have a question. How
Yes,
does
we can.
XDC Network handle smart contract wallets under AA?
So, what do you mean by that? Uh, I think not getting the question right. See, when you use account abstraction, so as we discussed before, so there is no requirement to have any other external wallet. So currently you have a, if I understand your question right, so what do you mean is like if you have application which is using any existing wallets on the ecosystem like XTC Pay or MetaMask or any other wallet for like working on the transactions. But if you are implementing account abstraction solution, you can also have like the wallet infrastructure like Web3 or Magic Link. So when you're combining these two together, smart contract wallets under AA. I'm just reading your question again. So how does XDC network handle smart contract wallets under AA? So there is nothing like we need to handle it explicitly. So when you create an account using like account abstraction, which we call it smart account. So there is like no need to handle like like similar to any other external wallets. But still, I think Etherspot also is working on some kind of UI which you can just go and check your balance and do all those stuffs. But yeah, currently like this smart accounts like resides abstractly inside the network, but you can like when you create a smart account, still you can query that on the Explorer. So maybe I can just try that out. But there is on high level, there is no level. I mean, there is no need of like explicitly maintaining any smart contract wallet similar to what you do with like any external wallets. So I'm just checking if I can just show you a quick demo. I mean, quick explanation of your query. Yeah, okay, yeah, I have that. So let me quickly share my screen. So, yeah. So what we are done here is like we have generated a smart contract account, which is see the term smart contract wallet or smart account, everything is the same. So instead of calling smart contract wallet, we are calling it smart accounts, which means the account is created with the help of a smart contract. So that's the term we call it like smart contract wallet or smart account. And here you can see this is one of the smart account created using account abstraction. You can just query it on the Explorer, similar to how you usually query your EOI address. So you can basically see what are the transactions happened so far on the network. So I think you can see there is 1 hour. We have done all these test transactions, right? You can just use it the way you're using your EOI address. I think hope that answered your query.
Thank you.
Thank you. As we have like reached to 4:27 now, so we are just having 2 to 3 minutes now. So thank you so much, Satish, and thank you, Nikhil, for the presentation and for the detailed explanation and taking all the questions here. So I have dropped the Telegram channel link here. So if anyone has any other questions, you can like directly drop your questions on XDC Innovation Labs tech support there, and we will be having our tech team to answer all your questions. And apart from that, like we have Kishan here, Kishan Balaji here, so who will be doing podcast. Like he will be starting the podcast for XDC India. So we'll keep you posted on our social channels about the podcast and the details about all the upcoming things from XDC Innovation Lab here.
Presentation. Thank you so much. Learned a lot from this.
That's good to know, Kishan. Thank you. And yeah, I would really appreciate it. Like if anyone is developing dApp on the network, so I would greatly encourage you to go through like account abstraction support, like which Nikhil explained, and the utility we have developed. So it's very simple to be integrated with any of the dApp you develop on the network. And yeah, of course, it's going to make the user onboarding seamless and great adoption to your product from the users. So yeah, if you have any questions, please feel free to leave it on xdc.dev. And also, I think Suresh shared the Telegram group. Yeah, we are happy to take it. Thank you.
In case if any of are coming, like if any of you have just missed any part, please feel free to watch our YouTube channel. So we have already hosted this event, this webinar live on our YouTube channel. So we'll be sharing the YouTube channel's link on our social platforms. So you can just take the channel link from there, and you can just go through all the whole webinar on our YouTube. And thank you so much, everyone, for presenting and for listening and like having an interactive webinar here today. Thank you so much. We'll upcome with more such webinars. Stay connected with us on all the socials. Yeah, and thank you so much.
Thank you.
Thank you.
Thank you, guys.